Hello everyone, this is Aditi Pal, final year student from AIIMS Nagpur, and today we are going to discuss about the chapter Organic Compounds Containing Nitrogen, or in short, we can say we are going to talk about amines. So this is the part 1 of the lecture. Part 2 will be covered soon. So let's start. First of all, what are the things that we are going to discuss in this chapter? So, first of all, we will know what are amines, then we will know about the structure of amines, then we will classify amines into primary, secondary, tertiary, then aliphatic, aromatic amines. Then we come to the nomenclature, that how are we going to name the amines. Then we will study about the methods of preparation of amines. Then we come to the physical properties, and then finally we'll discuss about the chemical properties. So let's start. The first thing is the intro. Amines are the derivatives of ammonia. So we all know what is ammonia. NH3 and N here has a lone pair. So we know that this is the structure of ammonia. Here is the lone pair. So happens? What it forms and N2 and N2 gas is released. So this reaction occurs in all in carboxylic acids as well as aldehydes and as well as ketones. So this is the Schmidt reaction. We saw that what is formed here, RC double bond O, NH and R. So this is formed in case of ketones, whereas primary amines are formed in case of in case of carboxylic acids. Now, what can we prepare Grignard's reagent? So our MgCl, this is our Grignard's reagent, and when it reacts with RNH2 and MgCl2. So we can get primary amines from Grignard's reagent also, and also from alcohol. Alcohol is taken and reacted with NH2 to form RNH2 plus H2O at 300 degrees Celsius. So we know that 300 degrees Celsius is not a favorable temperature to be attained. So we don't use these methods a lot. We have already learned the main methods of preparation of amines. These are the miscellaneous methods, but we should know them in case they put them in any reaction that what is formed. Okay, so we saw how our amines prepared. Now we will see the chemical reactions of amines. Chemical reactions of amines occur because amines are basic in nature and alkyl amines are stronger bases than ammonia. This one thing we should remember. Why? This is ammonia and this is an alkyl amine. This CH3 is an electron. It will plus I effect. It shows plus I effect. So these electrons are more easily available for donation. So increasing the number of alkyl groups, it will decrease soluble reactions. Why these happen? Because of their basic nature. That much we have to know. So first is alkylation. Now, all the three types of amines will react with alkyl halide. So all the three types of amines means primary, secondary, tertiary. They will react with alkyl halide to form quaternary ammonium salt that we already saw. Um, that that was ammonolysis of alkyl halide, but here the amines are only reacting with alkyl groups. Okay, so the replacement will take place till quaternary ammonium salt is formed. Okay, similarly, this was for aliphatic. Now, for aromatic, also the same case is there. They will also undergo this alkylation until they form quaternary ammonium salt, and means that all the hydrogen atoms are replaced and nitrogen has a plus charge, and here it is bound to any negatively charged ions. So quaternary ammonium salt is formed. So in both aliphatic and aliphatic and aromatic halides will form quaternary ammonium salts in case of alkylation. Now we move to the next thing, that is Hofmann reactions. Now we saw that whenever the amine will react with alkyl halide, it will form quaternary ammonium salt. Now this quaternary ammonium salt, when it is when it is given Ag2O and heat, then what happens? An alkene is formed, and amine is reacted to create a tertiary amine and an alkene by a treatment with silver oxide, water, and heat. So first of all, what did we do? Here we have a tertiary amine. Now what we did, first of all, we converted into a quaternary ammonium salt. Okay, so that tertiary amine already had quaternary ammonium salt. From what happens, an alkene is formed, and the alkene formed will be the one which has most substitution, means more substituted alkene will be formed. So in this case, this alkene will be formed. It depends which is more substituted, that we already know by hydrocarbons chapter. So if you treat this quaternary ammonium salt with silver oxide and heat, you will get a more substituted alkene. This we have to remember. So now, what is this? This is the Grignard's reagent. So when Grignard's reagent uh, is treated is treated with amine, primary amine, H2O, or alcohol or secondary amine, then in all cases alkanes are formed. So this we have to remember. This might be useful in questions, in solving questions. So this thing we have to remember. Now next, alkylation we saw, Hoffman degradation we come to acylation. Now what happens? Aliphatic and aromatic primary and secondary amines react with acid chlorides, anhydrides, and esters by nucleophilic substitution reaction. So we know what is acylation from previous chapters. So what happens? Aliphatic and aromatic primary and secondary amines. So both aliphatic and aromatic primary and secondary amines react with acid chlorides. So this is an acid chloride, uh, and a primary amine is reacting with the acid chloride to form what? By nucleophilic substitution. So here reaction is substitution nucleophilic to form what? So this lone pair of ammonia is attacking here, and the double bond is going here. And what are they forming? One hydrogen is leaving with Cl to form HCl, and the final thing formed is an ethyl ethanamide. Similarly, here this will attack here, this will go here, and HCl will move out to form NN-diethyl ethanamide. So we saw alkylation and we saw acylation. Now we move on to the next, that is Shorten-Bowman reaction. So that was, we saw aliphatic. If we take an aromatic amine and we do its acylation, then what happens? That benzanylide is formed. That is the same reaction mechanism will happen. HCl will come out, then this will shift first here, and then again it will shift here. So what will be formed? Benzenalide. So whenever an aromatic amine will react with acyl chloride, so acid chloride, then it is called, it has a special name, Shorten-Bowman reaction. So acylation's own part is Shorten-Bowman reaction, a special named reaction. Now we move on to the next, which one produce the highest reaction. So the aniline is given, OH is given, alcohol is given, and acid amide is given. So which produces highest effect? We have to know that alkyl halides have the greatest yield. This we have to we have to remember that alkyl halides will have the greatest yield in Friedel-Crafts reaction. Then we saw alkylation, acylation. Now we come to oxidation reaction of amines. So what happens in oxidation reactions? Carried out by KMnO4, potassium permanganate. First, it will form aldimine, and in case of secondary amine, first it will form ketimine. So now this aldimine, when treated with water, it will form aldehyde, and when this ketimine is treated with water, it will form ketone. So this we have to remember what happens on oxidation of primary amine and oxidation of secondary amine. Now what happens? Uh, there is a secondary amine. It is treated with KMNO4. So it will form tetraalkyl hydrazine. It was a primary amine. So in case of primary amines, we get it depends upon the uh, group that is attached with the primary amine. So in case of oxidation of primary amines only, we can get aldehydes and ketones. In case of secondary amine, what happens? This is a secondary amine, so it will dimerize to form tetraalkyl hydrazine. And in case of tertiary amines, we treat it with H2O2 to form trialkyl amine oxide. So these three things we have to remember: oxidization of primary amines, secondary amines, and tertiary amines. And also, this is a secondary amine. If we react it with Caro's acid, then we have to remember we get dialkyl hydroxyl amine. So this we also we have to remember. So this is the oxidation reaction of amines. We have to know that when in which cases we'll get aldehyde and ketone, we will get only in cases of primary, only in cases of primary amine. Now we come to another named rest. So carbyl amine reaction is only given by primary aliphatic and primary aromatic amines. And in this we take the primary amine and react it with chloroform. Chloroform and KOH in the presence of heat to form alkyl isocyanide. So first point to remember is what is formed. Alkyl isocyanide is formed and it has a foul smell, and this is how we recognize that the given compound is either primary aliphatic or primary aromatic amine. Now, primary amine, when heated with chloroform and KOH, alkyl isocyanide is formed. Okay, we know that, and it has a characteristic foul smell. We know that also. That is how we will identify primary aliphatic and aromatic amine. And the intermediate in case of this reaction is dichlorocarbene. This is CHCl3. What happens when NaOH comes? This H plus gets combined with OH minus to form water, and here it will be given minus charge. Now this Cl also leaves, and we are left with dichlorocarbene. That is the electrophile which will attack on the amine group to form alkyl isocyanide, which has a foul smell. Now, compound X on treatment with Br2NaOH provides C3H9N, which gives positive carbyl amine test. Carbyl amine test is given only by primary amines and primary aliphatic and primary aromatic amines. So, which is a primary aliphatic amine in this? Only this is the primary aliphatic amine. So, this will be the answer. And if we treat it with Br2NaOH, then the CO2 will disappear from here and it will form C3H9N. So, this is the correct answer. Then we come compounds A and B in the following. So first of all, this benzene when reacted with HCHO plus HCl, and then finally with AgCN. So first of all, we have to think that AgCN is there, then NC will be formed. So cyanide will not be there, isocyanide will be there. This we know. Now what will happen? HCHO in acid is there. So this SCHO when acid is there, then this H plus will go and attack on oxygen and O will have positive charge. So this positive charge is not stable on O atom, it will come to carbon atom. And then what will happen? This will attack on benzene. And when it goes and attacks on benzene, it will form something like this. And then what happens? This is positive charge comes on the benzene ring. Benzene ring will try to regain its aromaticity, and this positive charge will come here, and CH2OH will be formed. Then this H plus will act with OH, and H2O will be released. Finally, chlorine will come and react and attack on the CH2 positive to form benzoyl, to form benzyl chloride. So this will be the correct answer. Now, increasing order of nitration of the following. So, nitration we have to do means we have to treat with concentrated nitric acid in the presence of concentrated sulfuric acid. Now, we have to remember in case of amines, that is aniline, concentrated H2SO4 will give H plus. So, the H plus will react NH2 to form aniline quick. So this will come in the last. So these two options are gone. Now, in case of these, OCH3 has electron donating effect, so it will be the highest. Then CH3 has plus I effect, while in case of it has Cl, it has minus I effect. So the increasing order of nitration will be C, D, B, and A. So this will be the correct answer. Now, in this question, significant amount of meta product. Now, meta product will be formed by deactivating group, and now only we studied that it will form NH3 plus in case of nitration, and positive charge is meta directing. So this will be the correct answer. Now, what are the physical properties of amines? Physical properties of amines, that the lower aliphatic amines are gaseous in nature and they have a fishy smell. Then primary amines with 3 or 4 carbon atoms are liquids. So first gases, then liquids, and then solids. Gas, liquid, and solid as we move higher up in the series. Aniline and other aryl amines are generally colorless, but they colored if stored in outdoors due to atmospheric oxidation. So they are generally colorless, but they get colored if they are kept outside. Where lower aliphatic amines can form hydrogen bonds with water molecules, and hence they are soluble in water. We will also see this in the next class in case of solvation. So that is why lower are soluble and higher are not soluble, because higher cannot form those number of hydrogen bonds. The hydrogen bonding between primary amines. Now, organic solvents and easily readily dissolve amines. Okay, so amines are solvents, and primary and secondary and bonding. The intermolecular association is more prominent in case of primary amines as compared to secondary amines. Okay, this also we will see in solvation effect in the next class. And in tertiary amines, there is intermolecular association. Of course, there won't be, as boiling point is primary, secondary, and tertiary. The order of boiling point will depend on the molecular interactions itself. So this will be the order. We'll study this in detail in the next lecture. So we'll study about diazonium salts also in the next chapter, in the next lecture. So thank you for this lecture. I hope you all understood everything and best of luck. Thank you.